Hi, this is Brooke Hedrick. I'm recording my testing of the loudmouth Class A amplifier for the Contextual Electronics class. In the upper left-hand corner, you'll see the oscilloscope. The yellow wave is the input. The blue wave is the output. Below, you can see an image of the board we're testing. And then in the upper right is a function generator. Right now it's set on the kilohertz range and it's set for about 2 kilohertz. And the input voltage for the signal we're looking at is about 150 millivolts. We're powering the board with 5 volts from a bench power supply. Right here is the input power. Here's our output signal. That correlates to our blue wave on the scope. And over here is the input signal, and that's the yellow wave on the scope. So on the scope, you can see the yellow wave is showing about 150 millivolts positive and then 150 millivolts negative. That's the input. And then the blue output, we're looking at just around 500 millivolts positive and then negative. The resistors I chose on my Class A amplifier were going to give me about 3 times amplification based on the SPICE simulation. So we're looking at about what I'd expect. And I can, just for fun, I can change the type of wave. Right now we've got a sine wave. I can change to a sawtooth wave, or I can change to a more digital square wave. And if you'll notice, in all cases, we're seeing about a 3 times amplification. The divisions on the oscilloscope right now are about 500 millivolts per division. So each of those little squares, the height of them is half a volt. And like I said, I can change to different waves, and I'm going to get the same 3 times for each one. I can also vary the frequency. To do that, I will have to adjust the scope. So let's go down to 200 hertz. So I've adjusted the scope, and you'll see at 200 hertz, we're still looking at the same 3x amplification. I can go up to something more like 20 kilohertz. And I will adjust the scope here. So I think you can pretty much see without me doing it, but I'll do it anyway. All right, I've adjusted the scope, and we can still see the 3x amplification. So the good news is if we were trying to do something in the audio frequencies range, as I understand, be able to go from a couple hundred hertz all the way up to 20 kilohertz, and we're not having any issues. Things do get interesting though as I increase the voltage. This whole time, the input signal we've been using has been 150 millivolts or so. Now what I'm going to do is increase that voltage, and we'll see what happens. All right, I'm increasing the voltage very slowly. Watch the scope. Okay, notice when we got around, that's about 200 millivolts there. We have still a mostly nice and rounded bottom edge to our sine wave, and still rounded on the top edge. And we're watching the blue, the output. Now I'm going to increase the amplification, the voltage a little bit higher, and we're going to see something happen to our wave. All right, now we can see that we're still seeing the same approximate 3x or so of our amplification, but our wave is starting to look funny. It's getting clipped on the bottom. And if I keep increasing that voltage, so right now we're at about 330 millivolts. So around 200 was when things still looked pretty good. And then after that's when we started, our sine wave started to not look so good anymore. If I keep going, what I noticed that's interesting, and I don't know enough about how all this is happening exactly. So the output sine wave now, not only is it, instead of being a little square on the bottom, it actually has a little peak in the very bottom of that sine wave. So I'm not sure what's exactly happening. If maybe we'll learn that further in the class, but I just thought it was interesting that I do have kind of a limit, about 200 millivolts, and I'm not sure how low I can go because on my scope, if I got below 100 millivolts, my scope was having a hard time locking in on the signal. So somewhere around 200 millivolts and down. So I don't know how well that maps either to the audio signals that we'd be looking at amplifying, but it might be a fun test if I can find some output audio signal and see what it ends up looking like. So that ends my test, basic test of the loudmouth Class A amplifier. From what I can tell, it looks like it's working the way we'd expect. Thanks.